So good morning students. Today we are going to cover the backpropagation neural network. So in the last lectures we have already covered the artificial neural network, and the last topic was the types of a neural network, where we had discussed about the feed forward neural network and the backpropagation neural network a little bit. So let's start with the lecture. We have a content. The first one we will cover the fundamental part and the theoretical lines statements about the backpropagation. Then we will cover the architectures of backpropagation, where we will cover all the input nodes, weights, biases, and the activation functions are all about. Then we will have the procedure of that how it works, and finally we will cover with the algorithm part. So as we know, it's the concept that we that is initiated by the Henry and author team in early 1960. So it is the driven term, and if we explore the back propagation, we get that it is a backward propagation of errors. So finally, when we receive any error from the system, that error need to be back propagated to the network, and finally we adjust all the weighted and the given biases over there, and finally again reiterate the system, so that we can minimize the error what we are receiving, what we are getting when once we are comparing our actual outputs and the expected output. So this method help us to calculate the gradient of a loss function, and with respect to the all weights and the in the given network. So backpropagation neural network is used for the supervised learning and supervised training for the multi-layered feed-forward network. So when we talk about the supervised training, it means we are talking about some classification. So whenever we discuss a neural network, it means we are trying to design some classifiers that will classify the given class, finally yes or no, or whatever the we have set the value for the class. And it is a multi-layered feed-forward neural network. It means as we discussed in the previous lectures, that we have a single layer feed-forward neural network and the multi-layer. So multi-layered means we can have the set of hidden layers that we have to elaborate the different parameters in the hidden layer. So backpropagation works for the approximating the non-linear relationship. Usually we can work with the linear set, where we have some exact equations about the parameters, like we have a y equal to 2x. It means the y always be the multiply twice of that x. But most of the times in a current scenario we have a non-linear relationship, where we do not have any exact formula to calculate the parameter based on the given parameters. So backpropagation is especially useful for the deep neural network working on error prone projects. So suppose that we have some image recognition or speech recognitions, where we are expecting a less error. We can work with the time series data, like we have stock market data or weather forecasting or AQI index, air quality index. So in all the systems, in all the applications, we can apply backpropagation neural network. So this is the BPNN architecture. So in this architectures we have two input nodes, like I1 and the I2. So and the one hidden layer which contains two hidden nodes, one H1 and the second one is the H2. The input nodes having associated weights, like a W1 and the W2, W3 and the W4. In the similar way, the hidden nodes also has a corresponding weights in the form of W5, W6, W7 and the W8. We have two biases, B1 and the B2, so that we can have the constant values, and then finally we are receiving the error in the form of output layer. So we have a O1 and the O2 that obtains that helps to obtain our error. And in the bottom diagram we have The same diagram we can explore the first one, but the whatever error we are receiving here, this error need to be back propagated into our networks. So one by one, first into a output layer, then second into the hidden layer, the weight need to be adjusted there, and finally into the input layer. So all the weights one by one, whatever the existent layer to the error, that need to be handled first. So this is the in this diagram, the same way whatever error we are getting, that need to be back propagated in this output layer, and then afterwards into the hidden layer, and afterwards input layer. So in this way our back propagation neural network works one by one with the help of whatever error we are getting, with the help of whatever performance measure we have received. Like most of the times we use a mean square error. In the next slide we have a procedure of the back propagation, how it works usually. So as the diagram says, we can divide the complete algorithm, we can divide into two phases. In a first phase we have a forward pass phase, and the second phase we have a backward pass phase. So forward pass phase computes the functional signals, like a feed forward propagation of the input pattern signals through a network, and a backward pass phase computes the error signals, and it propagates the error backwards through network starting at output units. So obvious, the first existent layer from the output is the output layer. First we need to compute it and adjust all the weights one by one, whatever associated weights are given over there, and then we need to come out to the second layer if hidden layer presents there. So obvious, there must be some hidden layers because we are working for the multi-layer network, and finally we reach to the input layer where we are applying all the inputs. So this is the way our algorithm works based on the first forward pass phase and second for the backward pass phase. So this is if we try to explore the forward pass phase, how it works. So in the same way the diagram says, in the feed forward steps, an input pattern is applied to the input layer. So whatever input we are having here, we need to supply the values of these inputs and their associated weights. So all the weights need to be quantified, all the inputs need to be quantified. Similar way, all the hidden layers need to be quantified, and once we receive the output in the form of mean square error, so how this error need to be calculated, dear? uh, Obvious, once we have an input system, we are expecting some output. So if something given as an expected output and whatever we obtain as an actual output, so difference between the expected one and the actual one need to be calculated with the help of some performance measures. So MSC, mean square error, is a one of performance measure with the help of we are calculating the loss function here. So since all the hidden nodes have to some degree contributed to the errors in the output layer, so all the layers need to be tracked one by one, and the weights given to the system are adjusted over there. So the output error signals are transmitted backwards from the output layer to each node in the hidden layer, and that immediately contributed to the output layers. So, and this process has to be repeated till all the nodes gets traversed and all the weights gets adjusted, till we are receiving or till we nullifying the error what we are receiving or what we are getting in the form of gap of our expected and the actual output. So this is the working of the forward pass phase, and the same way we have a backward pass phase. So whenever the movement of the data or the movement of the system working in a forward direction, then it will be called as a forward pass phase. And once we are getting error, and error need to be back propagated to the system, then it's called the backward pass phase, and that is calculated with the help of a gradient descent. So gradient descent is nothing but it's an optimization algorithm that works to optimize the weights and the biases which are given to the system, which we have applied earlier, and after the iteration and iteration we are going to change these values so that we can nullify our error. Now so similar way, like we learn as a human being, we can learn from the mistakes. The same way, like a human, it will come up with the theories about how the sample fit into the classes. So once we receive a classes, suppose that we have a two classes, class C1 and the class C2, where we are having some expected output, but what we are getting as an actual output, and the difference between expected and the actual one will taken as an error, and that error need to be back propagated to the system. So this is the basic concept or the basic theory of the back propagation neural network. In the next one we are having a underfitting and the overfitting of a data. Dear, what happen when we are trying to generalize any system, we can face or we can come across the two situations where we can have some underestimation of the system or the overestimation of the system. So that under training can occur when the neural network is not complex enough to the detect or a pattern in the complicated data sets. So whenever we design a model that cannot prove or cannot best fit to our data models or a data set, then we can come across the situations where our data got underfitted into the system. So our data may far away from the straight line, whatever is being planned or whatever is being generated through the system. So this is the gap we can receive as an underfitted data. The similar way in the class, in a physical class, or the students or the teachers gap. So if we set a better standards, or the make a standards where most of the students are not getting fit into the statements or not getting learned from the system, then we can have some underfitting algorithms or underfitted model. But and on the contrary part, or the counterpart, overtraining can result in a network that is too complex and resulting in a prediction that are far beyond the range of the training data. So again, this is the overestimation. If we learn all the students in another way, where we have designed a too complex systems or the too sophisticated system, where each and individual are not comfort enough to learn the something, then it is called the overfitted situation. So whenever we design a model, whenever design especially a neural network or a back propagation neural network, we must take care about the such situations like a underfitting or the overfitting of the model. So look like in this line, this is the complex model where the model is not comfort enough to play a particular role into the system. So maybe some data points, maybe some populations, set of populations may not get impacted to the for the system. So these things can be that this such a issues can be occurred while we are training a data model like a data model like a back propagation neural network. So this is about the underfitting and the overfitting concepts into neural network. In the last one, we are having a direct propagation algorithms that divides in some set of steps. In a first step, what we need to do, we need to determine the architectures. So what architectures we are going through? What would be the input layer? How many inputs will be there? How many outputs will be there? What would be the set of hidden layers? And what would be the associated weights and the biases over there? In the second steps, what we have to do, we need to initialize all the weights and the biases to the system. So all the weights, W's and the B's, whatever having into the system, that need to be initialized, and that typically it belongs to the -1 to 1. And we need to pick a one learning grade, like as a human being we learn from our own. So maybe some people may learn too fast, some people learn as an average. So this is our representing with the help of an eta notations. So again it is given nearby a 1 or the less than 1. So and this process has to be repeated till the termination criteria gets satisfied. And finally, first we apply as an forward pass, as we discussed just few minutes back, and finally we will calculate the actual output with the help of input applied, whatever values we have given to the input nodes, with the help of multiplying weights, and then with the help of some activation function we need to sum all the things. While after we are receiving the input value from the system, we squash all the things with the help of activation function, and that's we here taken as an sigmoid activation function, and the output passed to the each neuron in the next layer. So once we receive the error, that need to be back propagated and adopt weights starting from the output layer and working backward pass. So this is the basic algorithm of the back propagation algorithm. In the next lecture we will discuss about the derivation of the back propagations. So each by one by one we will discuss about means how the inputs need to be calculated, how output need to be calculated, and how the weights will be adjusted into the output layer or the hidden layers. So thank you, have a nice day.